All right, in this video, I'm going to give a hint for the homework set 4.1 and 2. So let me start with the problem number 15, and then I'll try to give a hint for each other problems, okay, other questions. So in these problems, so let's see, 9,868 cases of heart pacemaker malfunctions, 4A5 were found to be caused by formula. So, and then, so from the first sentence, we can figure out the probability that what the heart the uh, the heart pacemakers uh, malfunctions they caused by a formula, which is for a 450 40 458 over 9,868, right? So we can figure out the probability that the pacemaker malfunctions caused by the formula. So we got the probability. So now now by the way, that's the 9,868. That's the sample, right? So keep in mind this. And then if the formula is tested in three different pacemakers, a random is selected from this batch of 9,868, and the entire batch is the accepted if there are no failures. And then what is the probability that the formula in the entire batch will be accepted? So the okay, to figure out the answer for the questions. Okay, so first we need to figure out that replacement is allowed or not allowed, right? Okay, so definitely replacement is not allowed, right? So the problem doesn't say that once we just choose the pacemaker randomly and then put it back. No, they didn't say that. So the replacement is not allowed. And then now next one, then is that okay? So since what the replacement is not allowed, that problem is not the and then so what that problems is not about the binomial distribution because the each uh, I mean the trier, okay, selecting the pacemaker randomly will affect the probability that we got the pacemaker. The we select the pacemaker after first selection. We got the pacemaker, which is caused by the caused by the formula, right? So each trier is affected each other. So each trier is not a the Bernoulli triers. Okay, so now the so that problem is not binomial distribution. Don't confuse that. Okay, so that's why which I told you that the probability we get in first we got the first sentence for a 458 divided by 908 9,868. That's probability not from the population but from the sample. Okay, so now then next one. See. mm, Next one, you should keep in mind this 5% guideline for the conversion calculations. When sampling without replacement and the sample size is no more than 5% of the size of population, treat the selections as being independent, even though they are actually dependent. So what that means, so in the problem, we selected three different pacemakers, right? So, excuse me. So three out of the the 9,868, that is the less than 5% of the less than 5%. So we have to by that the guideline 5% guideline we have to treat that problems. I mean each selections as the as being independent. Okay. So now then what's the okay? So the back to the problems. So here, the question is to figure out probability that a form that the formula in the entire batch it will be accepted, right? So in order to be accepted, what each pacemaker, um, malfunctions not caused by formula, right? So we need to figure out probability that what the a single pacemaker randomly selected, definitely malfunctions, not caused by formula. That's going to be 1 minus probability that the pacemaker selected randomly malfunctions found to be caused by formula, which is the 458 over 9868, right? So let me solve the problem in the sketch paper. So in these problems, um, let's say A, okay, is the set of all the pacemaker, okay. Let's see, pacemaker, the malfunction caused by the formula, okay. So set all the pacemaker, okay, malfunctions caused by formula, okay. So then probability of A is going to be using the classical probability, so 4 5 8 over 9868, right? Okay. So now then we want to figure out the probability that we select a single pacemaker randomly, not caused by a formula, which is going to be 1 minus using the rule for complement, right? So 1 minus probability of A. Okay, this is going to be 1 minus 458 over 9868. Okay, so now the now next one, the applying the since the what the replacement not allowed. Okay, so then the what let's figure out the decimal expression of that number first. Okay, so that's the approximately 0.9536. Okay, so now then since replacement is not allowed, the probability that we select the pacemaker not caused by formula is going to be 0.9536, right? And then next one, let's see, the in the second selections times, okay. So the second selection going to be what? In the second selection, selected, the second pacemaker randomly selected, not caused by the the formula, gonna be. I mean, if we don't apply 5% guideline, that's gonna be 457 over 9867 because we already select the one pacemaker. So okay, so in the sample size, in the sample, we already select the one pacemaker. So because in first, right? So the total number of sample size reduced by 9867. Okay, and then it's gonna be, give me a second. So it should be, there should be a 19, what, the 940 and A. Okay, where that number comes from? The number comes from the 9868 minus 458 and the minus 1. Okay, so now times, and then next one is 986 and then 6 and then 9407. Okay, so that one we got this one. So simplify this one, we're gonna get this 9409 over 9868. What does that mean? That number represents the number of the pacemaker main functions not caused by the formula. Okay, so actually we can plug in that fraction instead of this. Okay, all right. But if we apply we should apply 5% a guideline because the sample size is definitely less than 5%, only 3, right? So we consider the each trial as independent event, kind of. Okay. So now then we get this. The 540. I mean 0.9536 to the third power, because each event is independent. We have to consider each event as independent. Okay, so now, but when you calculate, when you figure out the answer, but the answer don't the round number before taking third power. Okay, so for example, so in my calculator, the okay, I figure out the probability of this one, probability that the pacemaker, and that goes by the what the formula. It's gonna be 0.95358, right? So I'm not gonna round, okay, until I take a third power, okay. So to the third power, okay, and then I'll just take a round, okay. So round to the problem says that round to 3 decimal places as needed. So rounding up to 3 decimal places, we're gonna get 0.867. Okay. So since 0.67, this is what? So the procedure is likely, right? So the procedure is what? Likely to result in the entire batch being upsetted, right? Because the probability is um, the 0.867 or almost 0.9, right? So all right, let's see problem number 13. So to look at the table. So the table show that the order accurate, not accurate for each restaurant A through D. Okay, and the question is this: two orders are selected. Find the probability that they are both accurate. So complete parts A and B below. Okay, so let's see. Question A: assume that the selections are made with the replacement. Okay, replacement allowed. So it means that what we don't. I mean, the conditional probability um, it will not be involved in the multiplication rule. Okay, so what I mean is this. So since the replacement is allowed, so probability that A and B is going to be probability P of A, right, times, and then probability that B bar A. This is a conditional probability, right? But since replacement is allowed, so probability conditional probability is equal to P of B. That is equal to P of B. So now that the probability A and B becomes just P of A times P of B. Okay, since replacement is allowed. So it means that what the probability that we get event B will not be affected by the event A. Okay. All right. So now then we need to figure out the probability that we select uh, the order randomly. Okay, is accurate, right? So we just figure out the total number of orders. Okay, and then also we need to figure out total number of order accurate. Okay, so we need to add all the other numbers in the table. That's gonna be total number of orders, well, either accurate or not accurate. Okay, and then we're gonna add all the numbers in the first row to figure out the total number of orders accurate. Okay, so we make a fraction that's gonna be probability, right? Okay. So in this problem, the probability is going to be 962 divided by 1001. Okay, 1101. Okay, that's going to be probability. Um, so give me a second. 962 divided by the 1100 to 1. It's going to be 0.8737. So okay, and then but the problem says that do not round until the final answer. Round to 4 decimal places is needed. So let me figure out the answer in the sketch paper. Give me a second. So we got the 962. divided by 1101. Okay, that's the probability that the randomly selected, the order randomly selected is an order accurate, right? The problem is what? The question is to figure out probability that two orders selected randomly are accurate. That's going to be this one square, right? Okay, because replacement is allowed. Okay, so if you say that A is the event that the first restaurant, I mean first order is accurate, and then let's say event B is the second order selected, which is accurate. Okay, then P of A and right, we need to figure out P of A and B, right? Isn't it? Because the question is to figure out probability that two orders, both in orders, two orders, definitely replacement allowed. Two orders are selected and they are accurate, which is this, right? Then since replacement allowed, that is equal to what? You see that here? This is equal to that PA times PB. Okay. Now there was a P of A. This one, 962 divided by 1101. What's the P of B? 962 divided by 1101. Since replacement allowed, the total number of the sample will not be changed. Okay, the total number of the event which are accurate, orders, set all the orders accurate will not be changed. Okay, will not be reduced because replacement allowed. So then we do this, to putting this number into the calculator to figure out the decimal expression and then round to 4 decimal places as needed. Okay, so let's move to the next problem. Problem number 13. Next question B is this. Assume that the selections are made with replacement. Are the events independent? Okay, so now replacement is not allowed. Okay, then the it means that events will not be, those two events are not independent. Okay, so the events are not independent. And then what's the probability? Let's figure out that in the sketch paper. All right, since the replacement is not allowed, we gotta figure out conditional probability. Okay, so now let's say uh, event A denote that the first order selected randomly is an order accurate, and the second order, okay, the selected randomly is also order is an order accurate. Okay, I mean two events, right? Okay, then we need to figure probability A and B, right? It means that both events, both orders are accurate, right? So this is going to be P of A times P of B bar A, right? Okay. Now we already figured out P of A, which is 962 over 1101, right? So that is equal to 962 over 1101. So what is this 962? This is number of total number of orders accurate, all of the restaurant, okay? And divide by total number of orders, either accurate, not accurate in the restaurant A through D, okay? The bottom one. Times this one, you see that we assume that event A already occurred, okay? And then replacement is not allowed. Keep in mind this. Since the event A is already occurred, it means that one order already selected, right? So total number of orders will be reduced by 1100, 1100, okay? And then the number of orders accurate also reduced by 961 because we assume that we already select the one order which is accurate, okay, from the sample. All right, so that's the probability P bar A. Okay, so we calculate, using calculator, we can figure out the decimal expression and then round to 4 decimal place. Okay, that's gonna be answer. Right, let's see problem 11. Use the data in the following table, which lists derived through order accuracy and popular fast food chain. Um, so yeah, so numbers are different, but the order accurate, not accurate, the data that's the yeah, so it's quite similar to the data we saw in question 13, right? So mm, assume that orders are randomly selected from those included in the table, and then see, let's look at the question. If one order is selected, find the probability of getting an order that is not accurate or is from restaurant C. Are the events of selecting an order that is not accurate and selecting an order from restaurant C disjoint event? What does that mean, disjoint? Disjoint event means that the two events don't have common outcomes. Okay, so what's the events is set of outcomes, right? Uh, the the specific satisfying some specific condition we are interested. So now, so it's the probability of getting an order from restaurant C or an order that is not accurate is well what these not I mean the day two events are not um disjoint because in restaurant C you see that 39 orders are not accurate. That's a part of the event um that what the getting an order that is not accurate, right? So let's figure out probability of getting an order from restaurant C or order that is not accurate. Okay, in the sketch paper. The first one, let's say a capital letter A is the event uh, denoting that getting an order that is not accurate. Okay, so oops, it should be set notation, not bracket. So yeah, so do not confuse with the capital letter A and B with the restaurant, name A and B. Okay. So A B capital letter A B don't represent the restaurant name. Okay, in the data table. I mean, and then event B is the getting an order from restaurant C. Okay, then we can figure out probability A and probability B. Probability that we get an order that is we select an order that is not accurate, going to be 147 out of 1140. The 147 comes from the sum of all the orders not accurate divided by total number of orders in the table. And the probability B is the going to be 286. Okay. Where that number comes from? That's the total number of orders from restaurant C. Okay. Divided by total number of orders all throughout restaurant, which is 1140. Okay. Now, since the we need to figure probability A or B, right? A or B gonna be by the using the addition rule, gonna be P of A plus P of B minus P of A and B, right? So we need to figure P of A and B. So P of A and B gonna be 39 over 1140. Why? You may just use the P of A and multiplication rule, which is a P of A and B is a P of A times and P of B bar A. But unless the problem is too complicated, I don't recommend you use this one. Okay, in that kind of simple problems. But think about this. Probability A and B means that what we need to figure out the probability that probability that getting on the order not accurate and from restaurant C as well. Okay, so then the 39, this many of the orders are not accurate and from the restaurant C. Okay, so that's the number of the orders, number of common outcomes belong to both event A and B. Okay, so when you look at the table, you see that number in the restaurant C column, and then the 39 is the orders not accurate from restaurant C out of total number of the order 1140. Okay, so that's the probability A and B. So we just plug in those three fractions into the formula. You can figure out the answer probability. Okay. Okay, let's see next problem. The problem number 9. Yeah, so we got the similar table. I mean, the similar table. Okay, so that's the table show that order accurate, not accurate, of drive-through restaurant A through D, but numbers are different from the other problems what we sell. So if one order is selected, find the probability of getting an order that is not accurate. Then I think I'm sure that you can solve the problems. You can figure out the probability of getting an order that is not accurate, which is the just figure out the total number of orders not accurate, which is 40. You see that 34 plus 58 plus 38 plus 15. That's the total number of orders not accurate divided by total number of orders, either accurate, not accurate. That's going to be probability. Okay, I think the problem is simple. Let's move to the next problem. So when a man observed uh, the sovereignty checkpoint conducted by a police department, ECL 687 drive over a screen, okay, and for arrested for driving while intoxicated. So based on those results, and we can estimate that POW is 0.00582, and they will where W denotes the event of screening a driver and getting someone who is intoxicated. And, and then what does PW bar denote? And what is its value? Okay, so let's figure out this one in the sketch papers. Let's see here. What's the W? W event W denote the drivers who is intoxicated, right? Then probability W gonna be 4 out of 687. Okay, so because the problem says that he saw 687 drivers were screened and 4 were the arrested for driving while intoxicated. So 4 out of the 687, that's gonna be probability based on the sample. Okay, so the approximate 0.00582. Okay, then what's the P of W bar? That's going to be what probability that we select the driver randomly, okay, and then who is not intoxicated, right? Okay, so I mean it's simple, right? So that's going to be what 1 minus P of W, right? Okay, but the problem doesn't ask that one, but let's see. Yeah, so I told you, so PW bar denote the probability of screening a driver and finding that he or she is not intoxicated. Okay, so let's move to the next problem. Oh, we have one more question. All right, PW bar. Yeah, I told you this is going to be 1 minus 4 over 6a7, right? You can figure out the answer, I'm sure of that. All right, next problem, question number 5. So in this problem, question is to find the probability that 4 or more cell phones, I mean, probability that his or her household has 4 or more cell phones in use. So here, 80 the peoples responded with 4 or more cell phones they use. So 80 out of the total number of respondents, which is 218 plus 286 plus 368 plus 139 plus 80. That's the total number of respondents, right? So divide the 80 by total number of respondents. That's gonna be the probability that his or her household has 4 or more cell phone in use. Okay, so for me, I got 0.073. Okay. So now next one, is it unlikely for household to have 4 more? 0.073 is definitely what greater than 5%, right? So consider an event to be unlikely if it is its probability is less than or equal to 0.05. But this is not less than or equal to 0.05. So no, okay, it's not unlikely for household to have 4. So is greater than, yeah, no, because yeah, so use it greater than 0.05. Okay, so so that's the yeah, I solved the most of the other problems in that homework set, chapter 4.1 to 4.2. So next time I'm gonna give hint for the other problems on homework, next homework set, chapter 4.3 through 5. Okay, so let me stop here.